Hello, Mrs. Craven here. Today we're going to start learning how to switch from one form of a quadratic equation to another form of a quadratic equation. This is our last lesson in Chapter 8, but it does connect directly to what we do at the beginning of Chapter 9, so we'll just make that smooth transition. I also believe we'll have a checkup on this starting on Monday, most likely, like we did this week with 822. So if you want to go ahead and print out this copy or have your spiral notebook in front of you and maybe your ebook open as I go through this lesson and follow along and take some notes, you'll always have this video to come back to should you need it. So to get started, we're going to revisit this idea of finding the exact vertex. That is a very valuable point to be able to find, because if you can find the vertex of a parabola, then you've got that line of symmetry and you're able to go through and find points on either side and x-intercepts and y-intercepts and get a pretty decent sketch. But again, just to even have that turnaround point is valuable. So we're going to take this equation right here and we're going to go through using the method from 822. I'm just going to rewrite the equation and I'm going to put it into factored form. I know my y-intercept is 10, but I want to find the vertex. So I'm going to take this and I'm going to put it into factored form. And to do that, I could do that with generic rectangles. And we could talk through this. Some of you may already be looking at this and saying, this isn't possible because the product of these two rectangles has to be 10x squared, and yet the sum has to be 8x, and there's no way to break down the number 10. 1 and 10, 2 and 5, that's it. Those are your only choices. 1 and 10, 2 and 5. And neither of those pairs add up to 8. So this is not factorable. Another way to say that, it is not factorable over integers. Just meaning that we wouldn't be able to put this into rectangle form. We wouldn't be able to come up with integer values here and here to be able to come up with our x-intercepts. Now, so does that mean that there aren't any x-intercepts? Well, no, not necessarily. In fact, if we went through this and we came up with graphing form of this equation, we would see, oh, hey, look, here's graphing form. We know that in graphing form, the vertex has to do with those two numbers. And if you remember that takes us back to lesson 823, where I walked us through graphing form. So the vertex is -4, -6. And we can even then take a minute, we can go and look at this. I'm going to put these two into Desmos. The first one would be y equals x squared plus 8x plus 10. Oh, I missed the x squared. Let's go back here and fix that. There we go. You can see there absolutely are x-intercepts. They're not pretty x-intercepts. They're a little bit tricky. And we can see also that this graphing form of x plus 4 quantity squared minus 6 gives us the exact same parabola. So we know that that's graphing form. The question is, how do you get from this standard form to this graphing form? How do you put this equation into this form? And that's what I'm going to walk us through. So if you move on down, to this next table, you can see here that we've got how to convert. This is your notes page. How to convert a quadratic equation in standard form to graphing form. We're going to go from this form to this form in a step-by-step process. And I'm going to do this with the equation that we just looked at. So the very first step in completing this, and then once I'm done, I'll go back and kind of talk about what this all means. But I want to walk you through the process so as not to make this be like an hour-long video. We're going to subtract c from both sides of the equation. C is our constant term. So I'm going to subtract 10 from both sides of the equation, giving me y minus 10 equals x squared plus 8x. And this is where that term, completing the square, comes into play. Because what I want to do is I want to take this right here and I want to make it into a perfect square trinomial so that I can write it in this format. X plus something or x minus something, that quantity squared. If I create a perfect square trinomial over here, then I can do that. That's why it's called completing the square. So the next step would be to add a blank. To both sides of the equation. Because this is where we're going to complete the square. So we have on the left-hand side y minus 10, and we're going to say plus a blank equals, and then we're going to have x squared plus 8x plus blank. And our goal now is to figure out what goes in to each of those blank spots. And the process that is highlighted in this third step is what is going to go in to those two blanks. So it tells me to square half of the value of b in the original equation. B in the original equation is 8. So I'm going to take half of 8 and I'm going to square it. This right here is the number that I need to record into those two places. So I'm going to have y minus 10 plus 16 equals x squared plus 8x plus 16. And again, if you remember when we talked about, and this was way before spring break, so I totally get it if you don't remember, but we talked about a perfect square trinomial. And in that perfect square trinomial, the last term, the square root of it, is half of the term in the middle. So the square root of 16 is 4. 4 is half of 8. That's a perfect square trinomial. So what I just did is I completed the square. So now I'm going to follow the next step. The next step simply says to simplify the left-hand side. So this becomes y plus 6 equals x squared plus 8x plus 16. The next step says factor the perfect square trinomial, or in other words, write it in factored form. So it's going to become y plus 6 equals, this is x plus 4, the quantity squared, and all of a sudden you can start to see that graphing form take shape. And then the last step is simply to solve for y. So I'm going to subtract 6 from both sides, and I've got it in factored form. I'm sorry, I have it in graphing form. So going through those steps, it's a 6-step process. It looks a little bit longer when I put it in this table form, but again, I wanted to break it into a step-by-step process. So as we go through, I've got a few more problems that we're going to practice. And we're going to walk ourselves through this process and look at a couple of what ifs. What if some different things come into play? But first and foremost, we're going to practice with these two functions. So I've got 2 more quadratic functions. And I'm going to go through those steps. And we're going to follow along and make sure that we've got things figured out. We're going from standard form. It's in standard form. We're going into graphing form. Then we're going to state the vertex and the y-intercept. So the very first step, would be to subtract that c term. So I'm going to subtract 7 from both sides, and I get f of x minus 7 equals x squared plus 6x. At this point, I need to put those blanks in. But before I put the blanks in, I am going to come over here and I'm going to find, this was step 1. Now I'm going to combine steps 2 and 3. It's going to be, this is 2 and 3. I'm going to put f of x minus 7 plus blank equals x squared plus 6x plus blank. So I need to find, I'm going to take b, which is 6. I'm going to take b, which is 6. I'm going to find half of b, which is 3, and then I'm going to square it. That's 9. So half of b squared, which is 9, and I'm going to add that to both sides. Now I've got f of x plus 2 equals x squared plus 6x plus 9. This was step 4. Step 5 has me subtract, I'm sorry, step 5 has me writing the right-hand side in factored form. This will be x plus 3, the quantity squared, and then I'm subtracting 2 from both sides, and I get f of x equals x plus 3, quantity squared, minus 2. I've now gone from standard form to graphing form. I've gone from standard form to graphing form. I know my y-intercept because the y-intercept comes from right here. So my y-intercept is 0, 7. My y-intercept is 0, 7. And I'm going to get my vertex from right here. So my vertex in this situation is -3, -2. The vertex comes from my graphing form. So I've got my y-intercept, I've got my vertex. I could go through and I could find my x-intercepts. I'm going to show you, though, the x-intercepts in this situation are not going to be friendly. If we go back to Desmos, I'm going to graph this new equation. So this equation is y equals x squared plus 6x plus 7. And if you look at the x-intercepts, you're going to see that they are decimals. We're going to talk about that, and I will walk you through that process of being able to solve those as we move towards another method for finding x-intercepts when they're not nice like that. But again, we do have the vertex at -3, 2. We do have our y-intercept at 0, 7. We would at least be able to get this point, and its mirror image over on the other side. That makes it kind of easy to work with. And once you have the vertex, we would even be able to then plug in some points just to get some values if we wanted to. All right, so let's walk through it one more time. I'm going to make this one a little bit more streamlined. So again, and notice they're putting it in function notation. F of x is interchangeable with y. It's the same thing. But we're going to keep it as f of x because I like that you guys are having exposure to the function notation. So we go through, we say f of x minus 11 equals x squared plus 4x. Now I'm going to take half of b and square it. So that's 2 squared is 4. So I have f of x minus 11 plus 4 equals x squared plus 4x plus 4. I add 4 to both sides. This becomes f of x minus 7. On the other side, I can rewrite that as x plus 2, the quantity squared. Then I'm going to add my 7 back over to get this in proper graphing form. I've got a y-intercept at 0, 11, and I've got a vertex at -2, 7. So that was a little bit quicker of a move through that. Again, you can go through all those steps. But now we're going to look at a couple of what ifs. The first what if being, what if the b term, excuse me, what if the b term is not even? Can we still do this? Can we still complete the square? And can we still get this into graphing form? And the answer to that is yes. I'm going to walk through the exact same process, that we just did. Nothing changes. So I'm going to subtract 2 from both sides. Then I'm going to take 5 and I'm going to divide it by 2, and I'm going to take that quantity and I'm going to square it. And when you do that, 2.5 squared is 6.25. So I've got f of x minus 2 plus 6.25 equals x squared plus 5x plus 6.25. Believe it or not, I have completed the square there. Half of 6.2, or I'm sorry, the square root of 6.25 is 2.5. That is half of 5. It is a perfect square trinomial. I'm going to simplify the left-hand side. So this is the beauty of using this method of completing the square, is that it even works with decimal values. And helps us with those decimal vertices. So I've got my y-intercept at 0, 2. I've got my vertex at -2.5 and then -4.25. Let's fix that up a little bit here. A little bit more space to write that out. -2.5 and -4.25. And again, we could go back to Desmos. We could walk through this and make sure that those two forms match. I'm not going to take the time to do that at this point. And if you have questions, please make sure you're emailing. The next what if, and I believe this is the last what if I have on here. Yep. Is what if one of the terms is missing. And in this case, it would be, because you wouldn't need to do this if the B term is missing, but what if the C term is missing? So in this situation, can we still, now mind you, this is factorable, but could we go through this process? Could we go through this process of completing the square and use that to find the vertex? You absolutely can. In this situation, it would just be that you don't have to subtract c from both sides because it's 0. So in this situation, I would take 10, divide it by 2. I would square that, so that's 5 squared. That's 25. And I would add 25 to both sides. Because we have to do that to keep this equation balanced. I can't add 25. I should have mentioned this long before, but I can't add something to the right-hand side to complete the square and not add that same quantity to the left-hand side. I have to maintain the balance of the equation. Hence the reason that we add the same amount to both sides of the equation. So then we have f of x plus 25 equals x plus 5, the quantity squared. And we get x plus 5, the quantity squared minus 25. At this point, we have a y-intercept of 0, 0. And we have a vertex of -5, -25. All right, so there you have that. That's walking through the idea of going from standard form to graphing form, which is called completing the square in the world of quadratics. You have lots of examples there to go back and look at. If you're looking for more of a challenge, if you're interested in where we're headed with this, because we are headed to the next level with this, how do we find the x-intercepts? Do we always have to go through and complete the square? Is there an easier way to do this? There is another way of handling this. So I would challenge you, if you're looking for something, that I did put problem 105 on here, and that's taking your basic standard form, and if you want to call it y equals x squared plus bx plus c, we can take that into graphing form using just the variables. I would be interested to see if you guys are able to do that, but that is a side challenge. I may reference back to that in our next post.